Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hi, and welcome to Geeks for Geeks. I am Siddhartha Hazra. I am an SD at Geeks for Geeks. Besides that, I'm also a candidate master at Codeforces. And today, I would be doing the post-contest analysis of Geeks for Geeks Weekly Coding Contest 152. So let's first talk about the feedback of this problem. So if I talk about the feedback of this problem, when I first saw the problem set, I asked the moderators, is it really for this contest? Like, they were on the easier side, but the problems were very good enough for beginners. Like, if I talk about the first two problems, I'm very much impressed by what solution they are using. Okay, like, yes, I knew the solution, of course, but it was impressive enough. I'm talking about the third problem. So if you are a person who is on the basic, on the easy and medium level, like a person who is doing easy and medium level, this contest is amazing for you, trust me. But a person who is very proficient with hard level problems, this contest would have been comparatively on the very easy side. Okay, so what is the feedback of this problem? Can I quickly have the feedback? What do you think this problem was all about? थोड़ा सा discussion type रखते हैं, not just so called जागरण thing. So let's first talk about, now let us start the very first problem. चलो देखते हैं comparatively. चलो, let me turn on. People are very happy today, ना? पूरा खुश हो गए आज सब. Was my second contest and I'm happy with my rank. Damn, good. Okay, this is good enough. So you're given an array of size n and you need to perform the frequency of I to n minus 1. Finally, you need to return an array of size n. Good. चलो देखें क्या क्या है. I think the first, chalo, let's see this. Let me share the screen. चलो, let us see this problem. देखो, ध्यान से देखना बच्चा. What you are asked? You are asked for each element find the frequency from I to n minus 1. This just means that you need to find the number of occurrence from that point till the last point. Now let us take an example so that we are better with this. If I talk about the very first one for A, it is occurring in here, it was occurring in here, and it is also occurring here. So for the first element, the output is 3. Makes sense? Now for the second element, one is occurring at itself and one is occurring at one more position. That is why the output is 2. Now for the third one, we don't have any 1 in the right hand side, so we have here. Now this one, we have it here and we have it here. That is why for this element the occurrence is 2, and for the last element we have this, and that is why the answer to this is this one. Okay, chalo. Now see, the basic idea is that if I try to think of in the very generic method, I would stand at this position and I would iterate on, and I would go to the end of n minus 1 and I would count the frequency. So for one element, we would be going n minus 1, that is, we would be doing an operation. That is, we would be sitting here and we would be iterating on all the elements to the right hand side. Let me just check if my iPad is visible or not. Else there would be no point in explanation. Chalo, visible hai. चलो 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 अब जल्दी जल्दी कर लेते हैं, comparatively easy है. So now see, just focus a lot in intuition. Okay, answer तुम्हें मिल जाएगा. You're not here for answer. You are here for just this problem statement, that if I see a solution like this again, how can I think of something like this? You are here for here. Your mindset should be something for this. Okay, now let's understand this. So I would stand at this position and I would count the frequency of all of them. Okay, then I would come here and count the frequency of all of them. Then I would again come here, count the frequency of all of them. Make sense? So now, what is the difference? See, for this number, we need to count all these numbers as well as this number. But for the next number, that is 2, we need to only count all these values, but we don't need the first value. Okay? Now for the third value, we need the count of this, but we don't need the count of this and this. So the very simple thing what you can do is, first find the occurrence of everyone. That is, I is 3 times, 1 is 3 times and 2 is 2 times. Then you go to the first one and you go like, what is the corresponding value? 3. Okay, I would write 3. Then when you move forward, you know that this contribution needs to be taken out. So that is why I would make this as 2. Now again I would see what is the occurrence of 1. The occurrence is 2. Then I know that I need to take out this contribution. Then I go towards 1 now. And then I go to here, and for 1 the value is 1. And then I go to the next 2. I know this contribution needs to be taken out, so this becomes 0. So now for 2 the value is 2. Now when I move forward, I know this contribution needs to be taken out, so this becomes 1. So now this becomes 1. This is the first way of solving this problem. You can count the frequency of all the values, and then as you move forward, you don't need 0 to I minus 1. You don't need the frequencies of the previous values that you have already processed. So you just keep subtracting at each point. Make sense? Now the very next step is, just give me a quick one. I won't check. Please generously one de do. I just want to know. Okay. Now the very next step is, this is one way we can solve up this problem. But if you observe, first we are counting all the frequency, and then at each point we are again building the answer. So see, dekho, for this the time complexity is big O of n. Okay, and this would pass for this contest. So if you are given this question in an online assessment, this is very good enough to go. But if the same problem occurs in an interview and the interviewer wants you to optimize more, then what optimization do you need to do? थोड़ा आगे बढ़ते हैं. because this is an easy question. Let us just broaden our mind a bit. तो थोड़ा क्या कर सकते हैं, first we are counting out the frequency, then we are filling up the array, which is basically we are traversing the array twice, that is 2n. We are doing 2n operation. So we can say, as this is constant, so we are not able to see, so we can try to do this in just one iteration instead of two. How can we do that? We can do that by simply filling up the answer from the end. See, if I go from that side to this side, and if I'm standing here, then all the processed frequencies I have shared is from here to here. What I meant to say is, if I start from the back and if I stand here, then all the previous frequencies that I have stored would be from that point to the last point. ठीक है? Make sense, no? Just if I go from there, I need to subtract from the same value. Okay, like it's just like if I have a total value of 8 and I start walking, so I would subtract the value. But if I go from this point only, then I just need to add value at each step, and that would be the sum till this point. So now, again building up the answer in this fashion, that first we come here, first we would hash the value, and then we would say, what is your rank? It is saying 1. Okay, I would write 1. Then I go to this. First we would hash the value. Then I would ask, what is the frequency that you have arrived to? Then I would come here, first hash the value, that would be 1. Then I come here, okay, so I would write 1. Then I come here, first hash the value, then ask, what is your value? You would say 2. Then again I come here, hash the value. Then I would ask, what is your frequency? I would say 3. And if you observe, this is the same value again. But here, I have just traversed once. So still that time complexity is big of n, but only difference is earlier we were using 2 traversal, here we are using 1 traversal. So interview or online assessment में यही फर्क आता है. Okay, in an online assessment you are only concerned about getting an AC and moving forward to the next question, because here time plays a very important role and no extra point is given for optimization. But in an interview, extra point is given for optimization. So interview and online assessments mindset should be different, even for this easy question. Do I make sense? Just give me a quick 1 or 0. Now, if I talk about the solution of this, comparatively, what I would do is I would make a map. Okay, I would make a map, and I need to return a list or an array list or a vector. So I would make this one. First I would hash the value. First I should hash the value and then save the frequency from the end. So we are doing this only in one traversal. So copying this, give me a quick 1 if this thing is done. Give me a quick 1 if you understood this, please. Give me a quick 1 na bachcha, jaldi de do. I would move forward to the next question. Batao do bachcha, you are also investing your time here on a Sunday evening. Contest हुआ, थोड़ा मोडाल तो आपको इलेक्ट्रिक देने तो पूरा ही नीचे गिर गया था. Okay, fair enough. Yep. Okay, so most of you have understood, so I would move forward to the next one. By the way, again, after a long period of time, I am again growing my beard to the fullest. So hope I look good, but still you can give your feedback. If I don't, if it is bad enough. So yep, let's move forward to the next question. Makes sense. So this one is the so chalo. See, See this problem. In this problem, a long story has been given, but in the note part, you have been given the question in a shorter manner. Okay, I don't know if they have missed this or whatever is the scenario, but see, this is the problem statement. Basically, this is the problem statement. See, the problem statement is number of different pairs such that a of I is equals to a of j and I minus j is greater than k. So it's just that you need to find equal elements. Both should be equal, like let's say both should be equal, that is, this, if this is x, this should also be x, and the distance between the index, that is I and j. So j minus I, it should be greater than equal to k. This is what I want. This is what I want. J minus I is greater than equal to k. This is what is want. Okay. Now let us look for this. So I would need to write the same array with the indexes 1, 2, 2, 1, 2. Talking about the indexes, this is 0, 1, 2, 3, and 4. Fair enough. And the distance that is required is 2. So now, for this value 1, we have only one occurrence, which is again, that is this one. So for this value, this is this. And 3 minus 0 is equals to 3, which is greater than 2. So this 0 and this 0 would contribute as a pair. Now for this value, we have this, but 2 minus 1 is equals to 1, which is less than 2, so it doesn't make sense. But this minus this, that is 4 minus 1 is equals to 3, which is greater than this. So this would also contribute to the answer. So 1 and 4 would also contribute to the answer. The very next one we have is this one. So for this and this, that is 4 minus 2 is equals to 2, which is greater than equal to 2. So 2 comma 4. So 2 comma 4. Okay. Now for this value, we don't have any 1 on the right hand side, and the one which is present on the left hand side is already counted. Doesn't make any sense, because a pair I, j and j I would be considered 1 only. Here it is written. So that is why we have 3 pairs with distance greater than k. That is why the answer to this is 3. Make sense? Now let's start to have the intuition for it. Dekho. Try to think of this. See, we have a value x. Let's say this is x. So this is, let's say x. This is x, 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 x. Okay. And the values are 0, 1, 2, 3, 4, 5, 6, 7. Okay. So let's talk about how many pairs this x would be making if the distance is equals to 2 or 3, if the distance is equals to 3. So it would make a pair with all the x whose distance is greater than 3. Whose distance is greater than 3. So all the occurrences which are less than k is not important for us for a particular pair. So all the occurrence which are less than k is not important to us. That won't contribute for this x. For a particular value, all the values would contribute, all the occurrences would contribute, but this occurrence won't contribute. Just take a look. If screen not visible, so quickly confirm if my screen is visible or not. Just quickly confirm if my screen was visible or not. I don't know. My screen should be visible. I didn't miss the visibility thing. Just quickly confirm if my screen is visible or not. Just quickly. Okay, it is visible. Thank you. मैं तो डर ही गया था. Okay, देखो. Now, let's saw this. अब थोड़ा सा और इसको अच्छे से सोचते हैं. Let's try to think it in a different scenario. See, for this value x, for this value x, for this value x, for this value x, all the frequencies which are on this side is important. Which are on this side is important. Please see this with care. For this x, this x would make pair with these all values. Let's just say that there are no elements on the right hand side for both of them. Now, for this element, see this with absolute care. ये वाला part बहुत ध्यान से देखना. For this element, these all elements would contribute. कुछ pattern बनेगा. Now, for this element, let's take a weird color or something. For this element, these all values would contribute. So what I can do is I can say, so just remember this picture. Try to build a pattern, something out of this. Okay. So for a particular value x, if I hash x minus, for a particular, I can say that, see, with reference to this, with reference to this image, try to think of something. For a particular index I, we should have the frequency of I minus k in our map. We should have the frequency of 0 till I minus k in our map. For example, for this element, we have all the frequencies there, which are, but not this one. So I would say for a particular index I, we would store all the frequencies from 0 to I minus k. Now, for the next frequency I plus 1, we should have all the frequencies from I to I minus k plus I minus k plus 1. Or I can say that first we would have the frequency of 0 to I minus k for I, and in the next step I can just add the frequency of I minus k plus 1. That would give me the value. And as I keep moving forward, I would keep adding the new frequencies, because for this one, for this element, only this was important. I moved further, then this element also got into this team. Then I moved further, then this element also got into this team. Now, how would I solve up this problem? See, अब time for you to see this with care. Okay, now see, we have something like 0, 1, 2, 3, 4, 5. and the values are 1, 2, 2, 1, 2. Okay, now we would see k is equals to 2, so we would start at 2. Okay, so first we would hash this frequency. So we would say 1 is equals to 1. सॉरी थोड़ा सा मिस्टेक हो गया, यहाँ दब गया. Oh, my iPad. Okay, I'm sorry, just wait a sec. Can't do anything, just wait a sec. My iPad is not working, just a sec. Okay, fair enough. The crash got resolved and I can move forward. Just a sec. देखो बच्चा. So if I am standing here, I would write the frequency of this one, that is I minus k, that is 2 minus 2 is equals to 0. So I would say 1. Okay, and as I move forward, so now 2's frequency of I minus k is how much? Nothing. Okay, so 0. So as of now 0. Now we move forward to this. So first we hash the frequency for this. So hashing up the frequency for 2. First we hash the frequency of this. Then we are hashing the frequency of this. Now 2 is equals to 1. Okay. Then for 1, what is the frequency? 1. Okay. Then we hash up this value. That is 2 now becomes 2. Now when we come to this, we find out how many values are there which are greater than k and have already been written. That is 2. So I plus 2. And that is how we are getting the answer 3 to this. So it's just that, see, I would again explain you in a very simple manner. See, 0, 1, 2, 3, 4, 5, 6. Okay. So for the first, let's say the value of k is equals to 2. So for this, we hash only till this. Okay. Now for the next value, we hash only till this. So as we move forward, we just keep adding the new elements. Okay. This is the idea, and how we are doing the observation. Every time we move this side, new element starts popping. Okay, with it, and the distance of k is kept as a gap. Like distance of k is maintained, and then we move forward. Like see, this is this element I plus k, and this is I. So till I we hash, and this distance is always maintained. Then we move forward. So this value gets added, and this value is again new value. Then this, like this. Okay. Hope I made sense. Just give me quick 1 or 0. So give me a quick 1 or 0. Just I want to know. I would explain you again. If you didn't understand that much, give me a 0 in the chat. No worries. Just quickly give me a 1 or 0 in the chat. There are 30 people at this point. So let me just check. Okay, no worries. Is my screen visible? No. Okay, देखो ध्यान से. So we need the frequency of I and j, but j minus I should be greater than equal to k. If j is greater, the distance between them should be greater than equal to k. We need this. And a of I should be equal to a of j. We know that. Now try to think like this. Okay. So we have 0, we have 1, we have 2, we have 3, we have 4. So let's say we have 1 here, 3, 3, 4, 4, and then we have 1, 1, 1. Let's say we just have 1, 1, 1, 1, 1, 1, 1, 1, 1. Fair enough? We have, let's say, something like this. So now, how many numbers, let's say k value is equals to 3. So this 0, 1, 2, 3, 4, 5, 6, 7. So this one would make a pair with whom all in the left hand side. This one would make pair with just this one on the left hand side. Now this one would make a pair with whom all on the left hand side. It would make a pair with these two. This one would make a pair with whom all? It would make a pair with these all. This one would make a pair with whom all? With these all. So at each point, while we move forward, see, the gap is maintained. The gap is maintained at each instance, and each time a new element is popping out. The difference between this and this is what? This element. And the difference between this and this is what? The upcoming of this element. And the difference between this and this is what? The upcoming of this element. So if we start at k and we hatch the value of I minus k, we keep the frequency till I minus k. It's just like a 2-pointer thing. So this is I and this is I minus k. So we would keep the frequency count of all the elements from 0 to I minus k. We would keep the frequency count of all this. And for this element, all the elements, for let's say this is x. So all the elements in this side is x that would contribute to the answer. Example के लिए समझते हैं. Let's say this is 1, 2, 3, and again 3, let's say. And this is 4, 5, and 6. 4, 5, and let's say this is 3. So for this I, if we have all the frequencies loaded till this point, then 3 is equals to 2, 2 is equals to 1, and 1 is equals to 1. So for this element would make pair with which all elements on the left hand side? That is these two elements. So we would just take out the frequency, that is 2. Then let's say if here 2 is there, then for this element, this till this point we would have, that is 4 plus 1, and we would take out this value 2. So the difference is maintained. So we come like a 2-pointer thing. One would keep a frequency from I to I minus k, and one is like I, and they both would move forward. Next time a new element we would hash and keep in the range, and here I would move to I plus 1. Okay, this is what I would do. And this is how the answer would be solved. So Umang San, Sandeep, am I clear to you? And Moody Engineer. By the way, your name is great. Just give me a quick 0 or 1 at this point. Do I make sense now? Umang San, done. Sandeep and Moody Engineer, can I have a solution from you all? Okay. Two people have understood. So just Moody Engineer, quickly confirm this. So now it's just like two pointers thing. देखो टू पॉइंटर है और इसके बीच में k है. So वहां से यहाँ तक जितने भी एलिमेंट्स का हैश है वो इधर रह जाएगा. And as we move forward, this distance is maintained. No? So इधर के सारे elements which are greater, which would be having get distance greater than k, kind of two pointer thing. This is I minus k. Okay, so this is I, and the other pointer is what? I minus k, and we are getting the value of a of I plus 1. And as we move forward, make sense? Just a quick just let me generate the URL again. Okay, but this looks, I used a different approach. So yeah, the most intuitive one would be to think of, like, if you're very equipped to data structures and algorithm, that is to do a lower bound on the frequency of the indexes. This is what you thought about. So why is the custom example saying that my answer is right, but when I send it to sim, it says wrong? I don't know what is the custom example and all. The range of n was wrong, so I don't know. Just send me your solution. We use Q for this. I don't know why I thought of this for the first time. I tried to solve it. Yes, we can use a Q, to be honest. Why? Because we would store all the frequencies. We would keep all the frequencies first. And then all the frequencies which are less than the distance k, we would remove that from the front of the queue. We can do that. But we need to store the frequencies for all the elements, and that won't be that much feasible. Okay, how can I send the solution here? You can't send the solution here. You need to connect with me over LinkedIn, or just first try to connect with Geeks4Geeks. If you're not able to find the answer, then you can send me a solution in LinkedIn, but I'm afraid that I would get very little time to debug your solution, because I obviously have other commitments too in my life. Yes, I did lower bound. Bola na? The most intuitive solution is lower bound, but for the beginners, this is more like, most you would have a wider search space in your head. Okay, chalo, let's go to the last problem. Third last problem. In the third last problem, you just need to do what is said. Okay, चलो देखते हैं, मजा आएगा. You just need to do what is said. Okay. See that lower bound, many of you have thought of lower bound and Q and different stuff. And to be honest, they are more intuitive. But you are using an extra space of indices there. Like, instead of, like, counting out the frequencies and storing the location. Storing the location would take more space, no? So that is why don't try to, like, that is just an overkill for this. I know that is more intuitive. I understand, completely understand. But kind of this is overkill if you understand. Like we can simply move forward and keep hashing this value. Okay, like this, and we keep hashing this side. Okay, kind of this. Now let's comprehend this. Comprehending this is all we need to do. So here we are told that we need to construct a tower. Okay, and are chosen from the array sequentially. If the height of the tower exceeds k, what do you need to do? Like you need to keep adding on the tower. And if the height exceeds k, okay, then the number of boxes would be removed from the top of the tower is given by I plus 1, which is I number of times it has exceeded I till now. So initially we have a blank tower and I has never been exceeded. So number of elements we need to pop out is 0 initially. Okay, initially 0. Now we come to the very first element, that is 2, and 2 is less than equal to 5. Then we come across 3. Now 3 plus 5 is less than equal, like it's less than equal to 5. So no need to worry about at this point also. Then we come across 6. We write this 6. But then we find out that it is exceeding k. So now we need to remember, we need to remove elements. So how many elements we need to remove from the top of the tower? We need to remove previous plus 1. That is k plus 1, 0 plus 1 is equals to 1. So we need to remove how many elements? 1. So we would remove this one. Then we come across 3. We write 3. Again this exceeds the value 5, that is 8. How many values we need to remove? We need to remove 2 values from the top. Removed. Then we come across 4. We write here 4. Now we need to remove how many values? 3. But we don't have 3 elements. Here it is written, if the current height is less than I plus 1, the tower becomes 0. Okay, the tower becomes 0. So the tower is becoming 0. Then we come across 1. We write here 1. It is less than equal to k, no worries. We come across 1. It is less than equal to k, no worries. In the end, final tower after the entire array is processed, that is 2. So we can process these all elements sequentially and this would give me the answer. But what are the things that we require? The requirement is that we need an insertion. We need an insertion to the last. We want to insert last. We need to insert it in the end. Top means what? We don't have any data structure which is like this. We all have different data structures which is like this. So we need to insert it at the last. This is just for the visualization of a tower, but we have a data structure like this. So we need insertion at the last. Then to remove elements, we need removal from the last also. Removal from last. बहुत last हो रहा है भैया. Okay, we need removal from the last, we need reinsertion from the last. So, which data structure does this most elegantly? The data structure SID does this in the most elegant way. Last in, first out. No, of course not. The data structure stack does this in the most elegant way, that is last in, first out. And we can do this as it is said. Okay, like what, Siddharth? See, something we can do something like this. We make up a stack. for this. Okay, and we have a sum with a sum till this point. Then we would first get the sum. Then we would push it to the stack. And if the sum is overflowing, what do we need to do? If the sum gets overflowed, what do we need to do? First, we would increment the count, that is number of elements to be removed, because this is given I plus 1. Then, while we have some elements, while we have some elements, and this is we have some elements, and the number of elements to be removed is still left. We would remove the top element, subtract it from the current sum, and then we would remove. So we would do this. Either all the elements needed to be removed is already removed now, or the stack is now empty. Whatever be the scenario, we do this, and then we increment the count. At the end, whatever height is getting remained, that is our answer. So do this as said, and we get the hint that this is a problem of stack when we are told this. The number of boxes removed from the top of the tower. So insertion from the back and removal from the back is last in first out, that is stack only. Okay, I hope I made sense. Just give me a quick 1 or 0 if I need more explanation over this problem. By the way, this should have been the second problem according to me, but I don't know why this is given a third problem. How come so many people did the fourth one? Because fourth one was comparatively easier to guess. So am I clear with the third problem? Just give me a quick 1 or 0. लेना मेरे भैया भैया और दीदी दोनों भैया और दीदी जल्दी से 0 और 1 दे दो भैया और दीदी क्विकली 0 और 1 दे दो Okay, let's move forward then. Chalo, this problem is, I think so, if you have seen if you know this algorithm and you know the observations for it, then this problem becomes easy. Okay, like this is one of the standard problems. Okay, like comparatively one of the standard problems. Okay, but if you don't know this algorithm, or if you have never studied this algorithm, I would say this problem would become a headache for you. Okay, now I would tell you how to draw conclusions here. So a person who is not good with graphs, I would say that kindly revise your concepts of a graph. देखो, whenever here in this question, it is told to create an array based according to some conditions. Okay, you are told to create an array. You are told to create an array based on some condition. Please see this with care. Some condition. Okay, and you are given n number of conditions. Okay, you are given n number of conditions. You are given number of conditions also. Some condition and then number of condition. And then whenever you are told, in any question, Given given conditions, given conditions, find a valid sequence. Find a valid sequence. Whenever you are told this, whenever in DSA, there is a 90% probability that this problem is of topological sorting. Whenever you are given conditions and you need to find a valid sequence respecting all the conditions, it is a 90% confirmation that that problem is a topological sorting problem. To be honest, it would be, but many a times what happens is sometimes it gives us a glimpse that this is topological sorting, but end of the day that is not. So I'm not trying to be overconfident with this observation. So I'm taking 90%, but whenever you're given this, given condition, find a valid sequence, you have this. Like Siddharth, for this question, this is fine. But what kind of statements are written in other problems like this? Let me show you. This is a very good example. See here also, you have M requirements and your task is to find the order in which you can complete the course. So here you are also given M conditions and you need to find a ordering or a sequence which respect all the conditions. So solve up this problem, that is course schedule. This is a very good problem over topological sorting, like the most standard problem of topological sorting that would make you understand what topological sorting is all about. So whenever you have this condition, do topological sorting. Okay. And to confirm this, you would observe the array would only contain positive or non-zero elements. And the array would only contain positive or non-zero elements. This confirms that there is no negative node in the graph. So now the idea is pretty simple. What we would do is, I won't use the Khan's algorithm or something like so complex, which is so complex to understand. What I would do is, like, is my screen visible? Yes. So I won't do something that complex. What I would do is, first I would make a graph. I would use a simple DFS algorithm. I would make a graph from 0 to 1. I would make a directed graph to from all the requirements. That is a very basic step to find topological sorting. 0 to 2. So 0 to 2. Then I would do a DFS for this. So I would start the DFS from any node. Here I would start the 0 DFS from 0. So from 0 would say go and finish the DFS of 1. When the DFS of 1 is finished, I would insert 1. Okay. Then it would go to the next neighbor which is unvisited, that is 2. So when the DFS of 2 is done, I insert 2 into the graph. Now as all the neighbors of 0 is done, the DFS of 0 is done, so I insert 0 in the graph. So it's just that first we build out a directed graph. In topological sorting, we build out a directed graph, and then after the DFS is done, insert the node, and then we reverse this to get the topological ordering. That is, we reverse this. So we have the topological ordering of this graph. We have the topological ordering of this graph. Okay, let me show you till this point and then we would discuss further. Okay, so building out the directed graph, how we would do this? we would start iterating over the requirements, and we would say make a directed graph from first to the second. So we are making a directed graph here at this point at line number 76. Then we are doing a simple DFS, that is visit me, invite me, but after me invite all my friends also. Just the simple code of DFS, only addition is that after the DFS is done, we then insert the node. This is the only difference. And after everything is done, we just reverse it. So here, instead of reversing, I'm just traversing it from the back. So traversing it from the back or reversing it is the same thing. Okay. Now, after this is done, what I would do is I would mark 0, 1 and 2, everyone with 1. So now, if for this 0, I would assign all the neighbors of 0 as +1. Whatever 0 is there, all the neighbors of 0 should be +1. So all the neighbors are 1 and 2. So 0 is 1. So this should become 2 and this should become 2. Now we go to 2. So all the neighbors of 2 should have value greater than 2. But 2 doesn't have any neighbors, so we don't assign anything. So the idea is pretty simple. We know that in a topological ordering, let's say 0, 1, 2, 3, 4. Let's say topological ordering is this. So what I would do is, I know that this element, whatever this element's value is this, all the neighbors of this element should have a value +1 to it. Okay, a simple application of topological sorting. So now what I would do is, I would first assign 1 to all the answer, and then I would say, we would take out the first element, then we would iterating on all its neighbors, and we would say, if its neighbor's value is less than equal to him, that is not possible. This person's neighbor should have a greater value. This is what is asked. 0 and 1. So 0, 1 should have a greater value than 0. So we just add 1 to it, because we want the minimum value, minimum integer. So minimum integer after 5 is what? 6. Minimum integer after 6 is what? 7. So we assign all the neighbors of the current index as +1. A simple application of topological sorting, basically. So I would copy this. If you're not understanding this, please ask me. But I'm afraid that I would be able to explain you the whole graph, then DFS, then topological sorting, and then solve of this problem. So the prerequisite of this problem is long enough. Other than that, if you know the prerequisite, this problem is comparatively is just an eye-opener kind of thing. A very standard problem of topological sorting. So anyone who has not understood this, give me a 0 in the chat. Anyone who know all the prerequisite but is not able to understand. Where can we get answers during contest? Damn, this is allowed in a stream? Asking all this is allowed in a stream? Okay, so if you have understood, give me a 0 in the chat, as around 20 people, 20 folks are waiting there in the live itself, and we have a lot of people around there. So I would end at this point, because there is no point in waiting for everyone. So a person who is watching this stream in the recorded version, feel free to give your views on the comments. And a person who was here till this point of the solution, consider waiting for few more minutes and then liking, and then you can comment on the video. That's it for today. Thank you and have a nice day. This is me, Siddhartha Hazra, signing off. Thank you. It's absolutely fine. Many have not. Thank you. Thank you, Aman.